Today, we are finishing up section 4.4, which started with factoring. So, what we're going to do is the factor theorem. A polynomial f of x has a factor of x minus k if and only if I plug in k and I get 0. If I plug in k and I get 0, it's going to be a factor. Okay? Now, what that means is, here we're going to determine if x minus 2 is a factor. What that means is, I'm going to use synthetic division, and if my remainder is 0, then x minus 2 will be a factor. So we're going to use synthetic division because it's faster. So remind us how to do this. What do I use in the little box for synthetic division? I use positive 2. And then I write my coefficients of the f of x, the polynomial. So 1, 2, negative 4. Remember, if any of them are missing, we have to put zeros in. And then we do synthetic division, which bring down the 1. Multiply by 2, we get a 2. Add them, we get a 4. Multiply by 2, we get 8. Add them, we get 4. Is x minus 2 a factor? No. Not a factor because remainder is not 0. If you have trouble seeing, I have one seat up here. I have seats out here where you could sit at my table, or maybe somebody would switch you if you have trouble seeing. But I don't want anybody, or you can sit on the floor too. I don't want anybody having to strain their eyes because they didn't bring their glasses to be able to see. This is your grade. This is your learning. Don't sit in the back squinting because you feel bad about moving. Come up and join me. I'm all the way at the beginning up here. You can come up too. There's 2 seats right there. Okay? Who wants going to move? I see you guys straining. Come on up. Does anybody else want to move? Because I see more than her straining. It's right here. All right. Determine whether x plus 5 is a factor of g of x. So we're going to put what in the little box? Negative 5. Then we're going to write our coefficients, putting a 0 in for any placeholder that we need. And because there is not an x to the first power, I had to put a 0 in that spot. Then we're going to do our synthetic division. So bring down the 3, multiply, get negative 15, add, 0. Multiply, get 0, add, negative 1, multiply, get 5. Add, I get 5, multiply, I get negative 25. Add, I get 0. What does that tell me? X plus 5 is a factor because the remainder is 0. Okay? Do I have 2 student practices? No. You guys try. You try. Wow, we need calculators? Okay. Oh, I see which one you're doing. I can do it by hand. What's 10 times 4 and 3 times 4? Did anybody get a remainder of 0? Okay. So if I were to give you this question, it would not be simply a yes or no question. I would actually look at to see what your remainder was to see if you did it right. Now, did I do it right? No. Oh, yeah, because it's a positive 52. See? I would look, and I make fun of you guys for taking your calculator out. I would look, what is it, 40 then? I would look to see that you got a 40, and that's why you wrote not a factor. So if you got not a factor, but you wrote 1 here, you would miss partial credit. Because yes, 1 would make it not a factor, but you obviously did something wrong. Okay? Example 6, factoring a polynomial. So this is show that x plus 3 is a factor, then factor f of x completely. So we're going to start out the same way. What's going to go in this box? -3. So we'll have 1, 3, 0, -1, -3. Why did I need a 0? Right, there's no x squared here. That would be the most common mistake people make, is not actually doing it themselves and never remembering that rule. So bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. I got 0. So it is a factor, but then it says we also have to factor it completely. So what I have to do now is I have to rewrite this as the equation with the variables back in it so we can factor what's left over. So remember the rule, if we take out an x, it was originally to the 4th power. This is going to be to the 3rd. So we're going to have 1x cubed. We're going to have no x squareds. We're going to have no x's.
You put x squared.
I don't know what you're talking about. We have, I said cubed, my hand didn't want to listen to my brain. Okay, 1x cubed, we have no x squared, we have no x's, but we do have a -1, and then the remainder. So we have to factor this completely. Yes, that's what we're going to do. This, okay, let's just start factoring. What's our first step of factoring? GCF. Is there a greatest common factor? No. So then this is 2 terms. Our options for 2 terms are difference of squares, which this is not a square, or is it a sum of cubes? Almost. We need to change it into what? Plus a negative. So what I was asking you last time, which is not really a necessary step, but just so you know how to do it, I was asking you things like, what cubed gives me x cubed? Right, this is x cubed, right? And what cubed gives me -1? It's -1 cubed, right? So this is how we're going to factor it. We'll take our parenthesis and we'll put what cubed here. X plus -1. And remember our second parenthesis. We just square the first thing, x squared, okay? And we'll square the -1 and put at the end, which becomes +1. And we always do subtract the 2 of these multiplied together, which is -x. And we'll simplify that a little bit. X minus 1 times x squared plus x plus 1. Can I keep going with x minus 1? No, because it's a degree of 1. It's linear. Can I keep going with x squared plus x plus 1? I hear both answers. Well, I don't hear both answers. I heard one answer and I saw head shake. Can I keep going? No. Martin, why are you saying yes? Just tell me your thoughts.
Couldn't you factor it out all the way though?
Why do you think we can factor it out?
Because
What's telling you though?
1 will equal 1x. So would it be?
Are you talking about this one?
Yeah.
Okay, well, I'm not looking at that. What here tells me I should be able to perhaps. Right, so if there's a squared, perhaps we can factor it. But, as I told you last class, it's never going to be factorable. The second one's never going to be factorable if it's a cubic. If it wasn't this perfect cube, then yeah, we would definitely try to factor it, okay? So now we have it completely factored. How many That's not a good way of asking it. The degree of the original was 4. So all of my factors, I should end up having 4 x's. So one of my factors is x minus 1, right? Another factor is x squared plus x plus 1, but that's only giving me 3 x's. Where's the fourth one? This is an x squared, that's 2 x's, right? This is 1x. When I'm just telling you, because you haven't seen this a lot, when I'm done, like if I multiply them all back together, I would only have an x cubed here.
Well, what about the x next to the x? It will multiply by the x, and it'll be x cubed.
This x? Well, that would be like x times x, that would become squared.
Would you put an x on the other?
No, it's in the directions. Show that x plus 3 is a factor. What did we do with that x plus 3? We used it. We divided it out already. Let me give you an example with numbers so you understand what I'm saying. Right? No, not multiplied together. I'm talking about the degree, and we don't use this x for the degree. When I'm talking about the degree, we only use the highest amount of x's and the highest amount of x's. And that gives me a degree of 3. But it was a degree of 4. Don't worry, I will show you where the other one is, but before I show you that, if I had the number 54, and I said, show that 54 is divisible by 2, and factor it all the way. You guys would say, all right, 54, that's 2 times... 54 is 2 times 27, and you'd say 27 is 3 times 9, and you'd say 9 is 3 and 3, right? And then you'd say 54 is not just 3 times 3 times 3. Because I told you to factor this out to begin with. That is one of the factors of 54. So what did I tell you to factor out to begin with? My finger is pointing to it. This is a factor. See how it says this is a factor? You see how it says that? That is one of the factors. So that has to be part of your answer. That's what I'm trying to show you. That has to be part of your answers because that's the other x. We already took it out. So we have f of x equals these 3 factors, but the degree of the 3 of these put together ends up being 4 because there was 2 here. Okay, that's what I was trying to get at is we can't forget about this one. This is part of the original question. All right, so let's try another one. This says student practice, so maybe you could start without me. Okay, start without me. You do.
Oh. Is that because the factor goes
Sorry.
Is that because the factor goes to the single digits, not the variables?
I don't understand what you're asking. You have to have the plus 0 because you have to have every single place value for those x's, all the powers of x, all the way down to no x's to do synthetic division correctly.
Okay.
So that's why you need it. Okay, so I did the first step. I messed up on the first step because when I talk, I make silly mistakes. So I had to redo that. I did the first step, and I got the remainder as 0, so this is a factor. then I have to factor whatever's left completely. So I need to see, originally it was a cubic, so what's this one going to be? Quadratic, right? And then I don't have to put in the plus 0, but I have to remember how to factor. So what's my first step of factoring? GCF. And it's factored. Let's write f of x factored all the way. If there's an x, a GCF, I usually put that first. Another factor is that x plus 1, but that only gives me quadratic. Where's the cubic power coming from? X minus 6 is that other factor. See? Yep, that's it. That's it. Okay. One Mississippi, just kidding. My kids do that to me all the time. I've become more immature since having children because I'm around it.
Around age.
Immaturity, yes. They're fun though. All right. I'm going to look at the degree, leading coefficient, y-intercept, and then we're going to figure out which equation matches the picture. And it's going to be easier than you think. And we're going to find the x-intercepts by looking at the picture. Okay? So let's just look at the very first one. What do we know about this? Degree? So 2, which is not odd. Oh, yeah, I'm looking at A. Okay. So we're looking for even. And what do we know about that leading coefficient? Positive. The y-intercept would be what? 0, 4. You plug in 0, you get out 4. So what do we know about even and positive with the end behavior? And we should really know this one because it's quadratic, and we just did that for 2 chapters in a row. This is a parabola that faces up, so that should be really easy to pick out. There's only one parabola that faces up, right? Okay, so this is going to be C, capital C. And then it says, let's find the x-intercepts, and we're going to write it in factored form from the x-intercepts. So I look at my graph here, and what are my x-intercepts at? Oh, I'm sorry. -1 and -4. Right? Those are my x-intercepts. So if those are the x-intercepts, we kind of have to think backwards. If x equals -4 is an x-intercept, remember how we take a factor and we solve it for x to find the x-intercepts? We're going to undo that, and we're going to make it look like a factor again. So we have to set this equal to 0. So how do I set that equal to 0? Add 4, and we get x plus 4 equals 0. So the factor is x plus 4 for that one. I'll do it again with x equals -1. So we're going to set it equal to 0, which means I add 1. And so my factor is x plus 1. So that's just going backwards with the stuff that we did before when we were solving. So now I'm going to write question A as a factored polynomial, and I didn't even factor it. I just went off the graph. So this is going to be x plus 1 times x plus 4 equals 0. Let's try that again. Let's look at B. What do we know about B? Degree. So 3, which is what? Odd. Well, I mean, yes, it's cubic, but what I need to know is the shape, so I know which graph to look at. So we're going to do leading coefficient is 1, so that's positive. Do they all have positives? Oh, they do. Well, that's really easy. So I'm not going to write that down anymore because they're all positive. Question?
I have a question.
Yeah.
I'm probably just, I don't know.
Okay.
So when you wrote out the factored form, you said it equals 0 versus
Yes.
f of x. Is that just like...
It's only because it says equals 0 there.
Oh, okay.
So all I did was like
I missed
factor.
that.
Yeah, factor this side and bring the 0 down. Okay, so for this one, the y-intercept.
2.
You plug in 0 for x and you get 2. Okay? So end behavior, if it's odd and positive, it's going to go from down to up, somewhere like that, down to up. We've learned this end behavior. So we're looking for a graph that looks like this and has a y-intercept at 2. That looks like my only option, doesn't it? Okay, so it's got to be f. Now, I'm going to write it in factored form just using the x-intercepts. So what is this x-intercept? X equals -1. And then x equals 1. And then x equals 2. I just went left to right, for those of you not saying it in the same order. I just went left to right. That's usually how I'll do it. Okay, so to write this in factored form, I'm not going to do this with every single number, but I'm doing it a couple more times so that you can see the pattern. So you don't have to write it out every time. So if I have x equals -1, then you have to set this equal to 0. Then I have x plus 1 equals 0. So what's my factor? X plus 1. So that'll be one of the factors. If I have x equals 1, what will be my factor? X minus 1. And if I have x equals 2, it'll be x minus 2 equals 0. My 0 like barely fit in there. All right, next one. We have cubic. So odd. And all of them are positive leading coefficients, so I'm not going to even write that anymore. Y-intercept would be, if I plug in 0, where will my y-intercept be? If I plug in 0, 0, 0. So we're looking for cubic. So it's going to go uphill, and it has a y-intercept at 0, 0.
So it has to be
Ooh.
no,
So it can't be B, so it's either B or
it's E. No,
it could also be A. Yeah,
it's
so
E because of the 2x, -2x. Yeah.
No, can't tell by that. I'm actually thinking what would be the best way to,
that's the
we could test a point. That would be a good way of doing it. Because let's just look at D for the little d down here. This also has a degree of 3, which is odd. So it's going to look like this as well. And then the y-intercept for this one is also 0, 0. Now, what's a point that A has that is different than E?
0. Oh wait, sorry.
Okay, so this one has -1, this one has -2. So basically if we test either -1 or we test -2 to see which one it works in, I'm not going to do both. I'm just going to test one of them. I'm just going to test one of them. I'm going to test the -1 because I think that one is easier to plug in than -2, but you don't have to do the same thing as me. So I'm just going to test that. I'll do it in a different color. I'm just testing -1. So if I test it, -1 cubed plus -1 squared minus 2 times -1 would be 1. Nope, -1 plus 1 plus 2. So that would be 2 equals 0. So it can't be this one. Let's test this one just to make sure I didn't make a silly mistake because I do that sometimes, you know. -1 cubed minus -1. So that would be -1 plus 1. Does that one work? Yes. So that means that D is A, and then C has to be E. Now we still have to write them in factored form by using their x-intercepts. So let's look at E first. X equals -2, X equals 0, and X equals 1. So how is X equals -2 written as a factor?
X plus 2.
Plus 2. Good, very good. Now how is X equals 0 written as a factor?
It should be X, right?
It would just be X. I mean, you can write X plus 0, but that is X. So I'm going to put that in front, because that's like a, if you were actually factoring it, look, that would be like the GCF. Okay. And then the third one, X equals 1, would be X minus 1 equals 0. And then question D, we have -1, 0, and +1. So the 0 is going to be a GCF in front, and then I'll have X plus 1, and I'll have X minus 1. Equals 0, sorry. All right, the last two are quartic. So these are even degree. And we've already discussed all of them are positive, so this one's going to be up. This one is also quartic, even, so it's also going to open up. What is the y-intercept for question E here? Plug in 0, we get out 4. What is the y-intercept? Ooh, why did I do that? So that one, if I plug in 0, I get 0. So we have different y-intercepts. We should be able to figure out which graph matches. So question E, 0, 4. Look at that fun graph. Yeah, that's D. That's a fun one. It does look like a W with side, right? Okay. That's going to be your next project. Make the coolest W ever. No. Yeah, okay. So then B must be this one here. Okay, we need to write in factored form, so let's look at D. We've got -2, -1, 1, 2. Can you please write it in factored form? And then I'll show you the answer. Same thing with the last question, F. We've got -1, 0, 1, and 2. You write those in factored form, and I will show you in a moment. That was one that I gave you. That was like a W. Yeah. Oh, shoot. I made another mistake. I have to erase. Not erase. Scribble. Okay, you have them done? So you should have X plus 2, X plus 1, X minus 1, X minus 2. If you have it in a different order, that is okay. I was just doing mine from left to right. But you can multiply in any order, so it would be okay if they were in a different order. I'm doing mine left to right. So you know where the X plus 2 came from. Came from the minus 2. Same thing with this one. Oh, with the exception of this one, I did put the GCF in front. So it didn't totally go by like left to right, because then the X would be in the middle and it would look weird. So I put the X there, and then I put X plus 1, X minus 1, X minus 2. So that didn't take too long to finish these notes. So the first assignment is a big ideas on this stuff. So I'm going to give you some time to start that before we go to our second section of notes.